Welcome to episode 2 of Sinking Black Swans. This episode I'm introducing a feature called FLASHTOBANG, where I try to take you from a concept to understanding as quickly as possible. This episode we're going to look at the risk matrix, and it's probably going to be the first of a number of episodes where we pull apart a tool which is so widely used in risk analysis, but which can be so poor and responsible for so much lack of understanding of risk. So it is really, truly quite an evil thing. However, it doesn't mean to be evil, and many of you who have used a risk matrix almost certainly did so with the best of intentions. So hopefully this episode can help you understand where those intentions may have gone wrong, and just to understand how that risk matrix may actually be transmitting information to others. So in order to push a little bit further forward, we need to understand what the point of a risk assessment is. And that perhaps isn't quite as easy as you might imagine. If you were to look across a number of pretty prominent and authoritative documents on risk assessment, for example, the UK government's Risk Management Assessment Framework, or the Society for Risk Analysis Quality Test, or even the ISO standard on risk management guidelines, you'd expect some quite explicit and directed guidance onto what a risk assessment was for. And the reality is, wherever you go, the focus tends to be on how to get the process right and what a good risk assessment or risk analysis process looks like, rather than why you might do it. It's often just assumed that you know why you're doing it to manage risk. Now, the purpose of risk management is defined in the ISO standard as the creation and protection of value. It states that it improves the performance, encourages innovation, and supports the achievement of objectives. And that's a lovely, slightly abstracted definition, but one for many risk managers that they may not identify with. It feels very enterprise risk management, very business focused, and certainly not quite the sort of thing that a risk manager in an emergency management organization might see as relevant to them. Now, there is a lot of cut across. I just don't really think that's that helpful a definition. So what might be a useful definition? Unfortunately, I don't really have one, but I can suggest some tools or some aspects of risk assessment that I think define its purpose. I think there's 6 types of purpose for risk assessment which I use, and I've certainly seen other people use in a similar way. So hopefully these are useful to you. The first is the exploration of a system, and it could be a system inherently managing risk, or it could just be a system where there's a feature you want to use risk management tools in order to better understand. And that is a really valid purpose. It's not necessarily going to generate a product or a feature which you present to anyone else. It could be a tool just for yourself in order to better gain understanding of components of a system, or indeed the system itself. And that's perfectly fine. The second is the prioritization and allocation of resources. So how do I decide where to put a limited workforce or money or assets in the best possible way? Now, we talk about this as being a feature of risk assessment. Many people might see this as the field of decision analysis instead. In reality, the separation of these two fields is slightly arbitrary. Risk assessment must, at its very initiation, be connected to the decision-making process. And therefore, you've got to make sure your risk assessment is going to generate appropriate and timely outputs to achieve the decision you're trying to make. So it's got to be able to do these things. The next purpose is the prioritization or sequencing of effort. This is slightly different from the prioritization and allocation of resources, because we're talking about the order in which you might address planning or considering them. Now, that may overlap entirely, but usually there are limitations not just on your workforce and money and assets to be able to deal with a risk, but also on the risk management, emergency management workforce who can actually start to consider the problems around it. And this can be quite an iterative process, because having conducted your risk assessment and started to prioritize looking more deeply into those risks, you may actually adjust where your priority for it is. And that's a feature people very often miss, especially when localizing a risk assessment, for example, from a national risk assessment to a local risk assessment. The next purpose is the communication of risk. So as you are trying to give to an audience a feel for why a particular activity is perhaps intolerable, something you need to stop doing, you might find a risk matrix is a useful way of showing that information. Now, there are other outputs to a risk assessment, not just a risk matrix. The risk assessment itself is a useful tool in generating some relative comparability of risks. But you need to have the risk assessment in order to be able to have the information in order to communicate the risk. In order to be able to say that something is broadly as safe as another activity, then you need to have conducted the assessment on those activities. Noting that comparison of risk is sometimes fraught with difficulty as well. Monitoring of risk over time is the next purpose. This is a really useful feature, though not one that's often seen. Because we are, by our nature and as organizations, so inherently caught up in both the moment and the future, we tend to only really look at the risk now rather than looking at the risk previously. But that's such a useful feature when you're analyzing risk management to understand, have we seen an increase in the likelihood or a change in the potential impact because of control measures? Are we getting better at managing the risk or worse? And that can really affect the risk assessment. It's not just about its moment in time, it's about where it's come from and hopefully where you're hoping to get the risk to. Usually reduced in impact and reduced in likelihood in many cases, if it's a negative risk. The final purpose, but certainly not exhaustively, that I consider with risk management is the exploration of strategies. You don't see this very often, and there are some very good reasons for this. If you are trying to determine the best allocation of resources, it is fairly inefficient to consider generating solutions or plans risk by risk in isolation to all other risks. Ideally, you would like to invest in features that improve resilience to a number of risks simultaneously. And it's a really useful way of being both effective and efficient with resources, but also hedging against the fact that you may not have enough resource to deal with everything at the same time. In fact, it can also lead to those resources becoming better skilled because they're more used. If you had a team, for example, that is trained to respond to one particular type of hazard and no other, and they rarely ever get called out to do anything, they may atrophy slightly as a capability and resource. So there are some benefits to making teams multifunctional, though again, some risks when you stack that responsibility or readiness. So the exploration of strategies allows you, if you're conducting it as part of a risk assessment, to look at a particular investment strategy and see how it might affect an overall portfolio of risks, usually on a risk matrix. So you may, for example, have a feature where you say we will increase control measures to a particular building, and that might see a reduction in likelihood across a number of risks, all of which have a common feature of being associated with people gaining access to particular areas. Or equally, you may look at reducing the impact of an incident or a series of incidents by improving emergency medical procedures or resources. And again, that could have a benefit across multiple risks, not just one. That can be quite powerful to see within a risk matrix where you're seeing a comparison of all of those risks moving in a particular direction. It's also particularly useful because it demonstrates how, if at all, you've considered the connectivity of different risks and how they might relate to control measures or reductions on impact or reductions on likelihood. For just a moment, I wanted to make sure you could see the probably most illustrative diagram of risk management from the ISO standard. Now, it's a relatively clear and interesting diagram. It certainly has all the components of risk management on it, but like a lot of diagrams that seek to abstract quite complex systems, it can look a bit simplistic. And certainly in this case, it's got everything in it, and tries to suggest a cycle by using a circle and the arrows around it. But it also does look a little bit linear, going from risk assessment through to risk treatment. And as a result, I'm not a huge fan of diagrams like this. They tend to encourage this consideration of both a risk at a time rather than multiple risks, and also a linear process. And that also lends itself to overall a poor risk assessment. Finally, before we get into the matrices, I just wanted to give an extract of the Society of risk analysis quality test. And you can see here the first category of multiple categories, I think it goes up to category M, of the sections or components of a risk assessment or risk analysis and things you need to do about it. So here we've got a checklist for the start of a risk analysis process where it talks about framing the analysis and making sure that it is appropriate for the decision making that it should be coupled with. And there's some great material in it. It's the first iteration that's ever been brought out by the SRA. I'm sure it will evolve to get even more refined, but it's a really useful checklist to consider. So now on to the main feature, the evil of the risk matrix, and why do I hate it so much? So what could go wrong with such a simple thing as a risk matrix? For those of you who have perhaps never seen a risk matrix, it looks like a graph or a chart, usually with likelihood and impact on the scales. Sometimes there are different features to those scales. Preparedness is something that's often considered, though not commonly, certainly not in national risk assessments. And you allocate your risk onto it as a score of XY coordinates between the impact and likelihood axis. Now, a feature that you may never have noticed, particularly if you don't do risk assessment as part of your job, is that there isn't really a consistent approach to whether impact or likelihood is on the X or the Y axis. Usually it's internally consistent because an organization will say, here is the chart you use and this is the way the axes are aligned. But if you were to search across the internet looking for things, you will find matrices which swap between impact and likelihood on the X and Y axis. And that lends itself to further confusion with when people are looking at risk and what they're expecting to see. If you are organizationally used to seeing likelihood at the bottom, then it's going to confuse you if you suddenly start seeing impact on there, and without carefully reading into the chart, you may well misread the chart. No different to misreading any kind of diagram, but because we are often quite bored with risk assessment and health and safety, it's very easy for us to make quick snap decisions when we're looking at these charts. It's not the only thing that can go wrong though, and I've got a risk chart here which I won't name the organization that produced it, but it is a real risk matrix that an organization produced in order to present risks and also in order to allow people to categorize risks with various different control measures or features. So when I talk about the problem with risk matrices including errors, there are a range of different errors to do with the resolution of them and internal mathematical errors. One of the most exhaustive documents in terms of criticizing risk matrices and some of these problems is the work of Tony Cox, referenced at the bottom of the slide here, on what's wrong with risk matrices from 2008. And he does it in a much more impressive and mathematical way than I can do. I'm just going to try and highlight some key features to you to help you understand why it is so bad. So in this particular chart, at first glance, it probably looks quite reasonable. We have 4 different categories here, from green to yellow to orange to red. Now, Cox would say that this is already a problem because there should be no more than 3 categories in a 5x5 matrix. I won't go into the maths on that. He does in quite good detail. However, it's worth noting that even if you don't hold to that, there are already problems in this matrix to do with the mathematical combination of the impact and likelihood in order to generate categories. So what does that risk look like? Well, we like to imagine that if a risk is put into a category, it should have the same or similar risk to any other risk in a similar colored category. And there are some mathematical reasons about why we would want to see that. ISO risk is a way of referring to it. It is extremely difficult to do within a chart, the best you might be able to manage is to have ISO risk boundaries, so between a particular score and another score, but it is a difficult thing to achieve. This chart absolutely does not achieve it. And if you are to look at the chart now, you'll see there's a number of components where there are huge problems. The first one to note really is that on the boundary between the red category and the orange category, you can have a score of medium high for relative likelihood and moderate for impact, which results in a product of 12. And that could be orange, but if it's just one category along and a medium likelihood but significant impact, it's the same score, 12, but it's in the red category area. Now that is a relatively modest difference in categorization between those two areas, but it gets a lot worse. So as we look down lower on in the chart, you can see that a high likelihood but minor impact gives a score of 10, and yet a score of 5 is orange when it is a low likelihood and a catastrophic impact. Equally, looking at the entire bottom row, you'll see nothing gets out of the green category area, even though the score goes up to 5. But if you look up at the column, again, the scores are no different from 1 to 5, but we go up through 3 categories as you're doing it. Now, while that is problematic from a mathematical component, it is understandable if you imagine that in this scenario, the writers of the matrix wanted to skew towards impact. So they wanted catastrophic impact to be more significant than high likelihood. But that can be achieved through weighting, and that's not what they did here. Rather than weighting, they just changed the color categories themselves, and as a result have created something which doesn't really make a great deal of sense mathematically, and it certainly limits the utility of the risk assessment. Ultimately, it actually makes the risk assessment a nonsense because you can't really use the numbers meaningfully. If you were to remove the colors from this and then try to sort the risks by their risk score, the product of likelihood and impact, you would not come up with the same answers as what was presented on the chart, and that is a problem because it becomes very difficult for people to really understand why things have been done the way they are. Other ways of solving this problem if you need to. The other issue on this chart, and it's unique not to this chart but to all categories of risk matrix based presentation of risk, is the suboptimal resource allocation. So if you are trying to decide a strategy, a single snapshot in time in a two-dimensional graph like this is going to always struggle. The example given here, and it's extracted from Cox's paper, talks about 3 different strategies which may reduce risk, and they all reduce risk by different amounts and cost different components. And the question is posed, well, which strategy would you select to have the best effect? What will be the most sensible strategy to choose? And the answer is, well, it depends on your budget. It depends on whether or not the risk measure or risk reduction measure, it lasts over time or whether it's a repeated cost. There's a lot more nuance to it. And unfortunately, you're not going to get that nuance from a risk matrix. But given that a risk matrix is inherently about supporting decision making, it's not helping you at all in making that resource allocation. Now, you may well yourself feel that you would never use a risk matrix for this, but they are absolutely used, and in particular this categorization, for simplified suggestions about how resources and time should be spent. In particular, you very often find people talking about the orange to red categories being the ones that you need to focus on and reduce risk on, which is fine, again, up to a point in that at least it's a system, but it may not be the optimum strategy. It gets worse though. So once you've seen this, you're never going to unsee it. But if you were to look at this slide, you'd note that it looks, again, fairly reasonable. You've got these rectangles and likelihood versus impact. But think back to ISO equal, the ISO risk. Why, if this is a 5 by 5 matrix, would it be rectangles? it should be squares, because surely there is an equal category from 1 to 2 to 3 to 4 to 5 along impact as in likelihood. And scaling them in a way which doesn't really represent that can just throw the eye off, but it can also cause people to misread the slide, because it can push risks to the extremes of the slide unnecessarily, especially if you're not consistent with how likelihood and impact are displayed on the axes. So nice smart square graph. And again, if you look out, you will see charts that do use squares, and more power to them for doing so. This work, by the way, is predominantly from Sutherland et al. On how people understand risk matrices and how matrix design can improve their use. So this isn't just the view of Steve or even of some scientists that haven't really thought about this. This is the basis of actual study using risk matrices, presenting them to people and asking them, did this actually mean what you thought it meant when you looked at it? And in their study, which I absolutely commend you to read, there's some phenomenal work where they ask people a number of questions about matrices presented in different ways, and find, as we've been talking about, that people do not interpret the risk matrix as was intended, and that there are ways of improving them. So the last point of improvement that I'd like to talk about is about the linear versus log scale problem. And this is definitely something that if you're an emergency planner that you will have seen, but again, it's very common to see across all risk assessment, which is that we refer to a 5x5 matrix and we allocate a number from 1 to 5 in each of these categories of impact and likelihood. And we'll often give a key describing what that means. So we will translate often a quantitative range to a semi-quantitative single number, categoric number, 1 to 5. Now, that's problematic by itself. It throws away a lot of data, but it's also challenging for people to read as they're going through this, because as they read through it, they are comparing a risk which may be impact 1 versus a risk which may be impact 2. But the reality, as we're showing in this chart here, is that it may be going up in leaps from 1 to 10 to 100 to 1,000 to 10,000, where we're going up by power 10 each time. Now, for those of you not particularly comfortable with maths, that's what we mean by a difference between a linear and a log scale. In a linear scale, going for, you'd imagine each of those leaps up to be an equal amount. So from 1 to 2 to 3 to 4 to 5 would be linear. From 1 to 10 to 100 to 1,000 to 10,000 would be log. This is even more challenging than the square versus rectangle issue, because the difference between each of these columns is not regular either. So as I go from column A to column B, the risk impact in this case goes from 1 to 10, a difference of 9. But as I look towards the right hand side of the scale and I go from column C to column D, if this was the linear numbers that you would normally see on it, it would be going from 3 to 4 in impact terms. But the difference in log terms is 900 units. So we're going from 100 to 1,000. So you get a compression of both impact, and if this is used on the likelihood scale, the same for likelihood, as the graph appears to be uniform, but actually is compressing impact or likelihood into squares. The lowest density is at the bottom left-hand side of it, where we give far more space for much lower and lower likelihood, or potentially higher likelihood, depending on the orientation of it, risks, up to the far right-hand side of the scale, where you can have a really significant impact, but really compressed down. Sutherland suggests that there are a number of different ways to deal with this. One of them is to actually label the scale as we've done here, so that you can actually see that it is going up by significant amounts, and that can have some benefits. The other is to change the lines, and we're not going to show that on these slides here, but I commend you looking at the paper to see it, where you would actually have a difference in the size of each of the columns to demonstrate the increasing amount of impact in each of these areas. So at the far left hand side of the scale, column A would be far narrower than column E. And the same can be true of likelihood as you're going through this. So that's a really fast whip through the challenge with risk matrices. There is so much more to say about them, but the first episode on this here is really just to get you understanding some of the key problems and to encourage a little more investigation into perhaps how you're using them, and to direct you to some of the resources that can help you improve your approach to risk matrices, and really just to warm you up to some further problems that we'll look at in risk analysis in future episodes. Thank you for listening.